Today we're going to talk about measures of spread. So measures of spread or variation is how widely the data vary. The range is the difference between the greatest and the least value. And we're going to divide our data into what's called quartiles. So quartiles divide a set of data arranged in ascending order into 4 groups, each containing about 25% of the data. This creates something called a 5-number summary, which we will see in our example. Okay. So a fundraising event is held at a school cafeteria each year. The yearly fundraising event had the following attendance for the last 9 years. Okay, so we have this. So we're going to find our 5-number summary, which is going to be the minimum, the maximum, the median, and then the lower quartile and upper quartile. Okay, so first I'm going to put our data in order from least to greatest. So then I'm going to fill in my number summary here based on that. Okay, so my minimum is 38. My maximum is 69. Okay, the median is the middle number, so cross those off. So my middle number is going to be 48. Okay, to find the first and third quartile, that is going to be the median of the remaining sets. So we will not include the median in here. So the median in this case is going to be the average of these two, which is 42 plus 45 divided by 2, which gets me 43.5. If rather than one median, you had 2 that you split, then you would include those data points in the partitions. Q3, or the upper quartile, is going to be the median of this set of data, which will be the average of 55 and 62. Okay. Once we have our find number summary, we can find something that's called the interquartile range. Okay, it is the distance between the upper quartile and the lower quartile. So we're just going to take this minus this. 58.5 minus 43.5 gives us an interquartile range of 15. Okay. An outlier is either extremely high or extremely low compared to the rest of the data. There is a nice numerical way to find this. Okay, you're going to find, we're going to take the interquartile range and multiply by 1.5. So we're going to take 15, multiply that by 1.5, which gets us 22.5. Okay, and then we're going to subtract that value from the lower quartile. That's our lower boundary for the outlier. I'm going to take my 43.5 and subtract 22.5, which gets me 21. Okay, so the lowest value would be 21. Well, in my set of data, the lowest I have is 38, so we're okay on that end. For the upper boundary, we're going to take the upper quartile, which is 58.5, and add the 22.5, to get 81. Okay, well, if I look at my set of data, and I wrote the wrong number here, but my biggest value is 96. Well, 96 is bigger than 81, so that means 96 is an outlier. Okay, so you go ahead and try this one. Find the 5-number summary, the minimum, lower quartile, median, upper quartile, and maximum, the inner quartile range, and then if there are any outliers. Okay, so in each of these, you put your data in order from smallest to biggest. Okay, so the minimum for this one's 65, maximum is 95, the median was 86. Then for this one, the average of these two is 81.5, so that's my lower quartile, or quartile 1. Average of 88 and 92 is 90, so that's my Q3. The difference between those values is 8.5. If I multiply 8.5 times 1.5, we get 12.75. 81.5 minus that inner quartile, the 1.5 thing, is 68.75. Okay, so that makes 65 an outlier. If we add 12.75 to 90, we get 102, but we don't have anything past that. For this one, our minimum was 32, maximum is 98. The median ended up being the average of 54 and 60. So then to find my Q1 and Q3, we'll just do the medians of each of these set. So the median here is 50, so Q1 is 50. Median here is 65, so Q3 is 65. Difference between those is 15. Multiply that by 1.5 gets us 22.5. Subtract it from Q1 to get our lowest value would be 27, so we're good there. The biggest outlier would be bigger than 87. 98 is bigger than 97. Or 87, so that is an upper outlier. The next way we can look at spread is with something called the standard deviation. Okay, this is calculated, shows how the data deviate from the mean of a set of data. The variance of the data is the square of the standard deviation. So we're going to do this by hand, but then I'm going to show you that ideally, we're going to use the calculator. So employees at a law firm keep track of how many hours they work each week. 44, 48, 44, 40, and 59. Okay, so the first thing we're going to do, to find the variance, we square the difference between each number and the mean, then divide by the number of values. So the mean is going to be the sum of those. We get an average of 47. Okay, so there's a symbol here. This is a lowercase sigma. Okay, so the standard deviation, this is our symbol for standard deviation. The variance is this squared. So it's calculated by taking the difference between each of these numbers and the average and squaring it. So 44 minus 47 squared. 48 minus 47 squared, 44 minus 47 squared, 40 minus 47 squared, and 59 minus 47 squared, all over the number of terms. So this gives me 42.7 is my variance. The standard deviation then is the square root of that. Which is 6.51. So the smaller that number, the less spread out the data is. The bigger that number, the more spread out the data is. But we're going to use the calculator. So I'm going to show you how we could get that same thing in the calculator using something called one variable statistics. So our first thing we're going to do is do stat and edit. Okay, if there's something in your data tables here, you're going to highlight that and hit clear enter. Okay, then I'm going to go ahead and type in my 5 numbers, 44, 48, 44, 40, and 59. Okay. Entered it into list 1. Now I'm going to go to stat over to calculate, and we're going to do this very first thing, one variable statistics. Some calculators will look like this, and we're going to put list 1. There we go. So above the 1, 2, 3, you see L1, L2, L3 in blue. So you do second that. We don't really care about that, so I'm just going to hit enter. And we get our average, which we found. So this X bar, and I wrote these things down so we can label them. This is the average or the mean. Okay. We don't care about some of these. This thing right here is our standard deviation. Okay, N is the number of data points. Okay, and then if you scroll down, you're going to see our 5 summary. Okay, so these are our min, Q1, median, Q3, and the max. So I want you guys to go ahead and try finding the means and the standard deviations for these 2 sets of data. Okay, so the mean here is 69.5, the mean here is 75.5. So the left-handed pitching is much faster, or somewhat faster than right-handed. The standard deviation here is 2, the standard deviation here is 4.8. So that means there's a higher variance, or there's a wider range of values here than there is for this one. So those are measures of spread.